my name is Atira Najwa binti Azri. My student ID is 2025860782 and I will be presenting question number 2.
Assalamualaikum and hi, my name is Nur Inshra Basisha binti Muhammad Sulaiman. My student number 2025853136, and I will explain question number 1 and question number 4.
Hi, my name is Sharifah Atira Said Ali. My ID number 2025817776. I'm going to explain to everyone question number 3.
Question number 1. I will explain the meaning and technique of differentiation. Differentiation is a process used to find the rate of change of a quantity with respect to another quantity. Some technique of differentiation are: number 1, our rule d over dx brackets x power n equal to nx power of brackets n minus 1. Number 2, product rules d over dx bracket uv equal to u bracket dv over dx plus v bracket du over dx. Number 3, quanting rule d over dx brackets u over v equal to bracket v bracket du over dx minus u bracket dv over dx over v power of 2. Number 4, chain rule d over dx bracket f gs equal to f prime gs multiplied by g prime s. Number 5, implicate differentiation used with y is not writing explicitly in terms of x. Number 6, trigonometric differentiation. For example, d over dx bracket sine s equal to cos s. This technique helps us differentiate different type of function.
Next, we'll be moving on to question number 2. Find dy over dx for the following function, which is y equal to ln 2 plus x cubed secant 2 minus x. So for this question, we'll be using product rule. So for the first step, we need to find u prime and v prime. As we know in the question, u is equal to ln 2 plus x cubed. For differentiating ln x is equal to 1 over x, that is the formula. So we differentiate ln, we get 1 over 2 plus x cubed. Then we need to differentiate what's in the bracket. So 3, bring it to forward, we got 3. And then we minus the power, which is 3 minus 1, we get 2. Then we solve, we need to multiply the 2, we get 3x squared equal to 2 plus x cubed. Next, we need to find v prime. V is equal to secant 2 minus x. To differentiate secant, we use the standard differentiation rule. The derivative of secant x is secant x multiplied tangent x. So we got v prime equal to secant 2 minus x multiplied by tangent 2 minus x. Then we also need to differentiate inside the bracket, which is we got negative 1. We multiply all of them, we got negative secant 2 minus x, tangent 2 minus x. Now we know all of the term, we can substitute inside the product rule. We substitute and we get ln 2 plus x cubed multiply negative secant 2 minus x, tangent 2 minus x, plus secant 2 minus x multiplied by 3x cubed over 2 plus x squared. Then for the final answer, we got secant 2 minus x multiplied by 3x cubed over 2 plus x cubed, negative ln 2 plus x cubed, tangent 2 minus x. So for the next question, B, we need to find dy over dx for the function y equal exponent to the power 3x squared over tangent x. So for this question, we need to use quotient rule because it is division. The quotient rule formula is dy over dx equal to vu prime minus uv prime over v2. First, we find u prime. So we know that u is equal to exponent 3x squared. So we need to differentiate exponent. For differentiating exponent, we first write back exponent 3x squared. Then we need to multiply the inner function, which is 3x squared. We differentiate, we got 6x. Then we multiply the two function, we got 6x exponent 3x cubed. Next, we need to find v squared. V is tangent x. Then differentiating tangent x is equal to secant 2x. So we got secant 2x. Now we got all of the term. We can just substitute inside the quotient rule. We substitute and we will get exponent 3x squared multiply secant 2x minus tangent x multiply 6x e exponent 3x squared over tangent x squared. Then we will simplify all of them. For the final answer, we will get exponent 3x cubed bracket 6x tangent x minus secant 2x over tangent 2x.
So for question 3, we need to separate it into a different part. So for first part, we need to differentiate cos for e2y minus x cubed. So first, let u equals to e2y minus x cubed. Then we differentiate cos u for the final answer we're going to get is negative 4 cos cube u sin u du dx. So next step, find du dx. For du dx, we are going to use chain rule to differentiate e2y minus x cubed. For e2y minus x cubed, we are going to differentiate it to become 2e2y dy dx minus 3x squared. And for the final answer, we get negative 4 cos 3 e2y minus x cubed sine e2y minus x cubed times by 2 e2y dy dx minus 3x squared. So for the next part, we are going to differentiate negative ln y square. So d over dx, negative ln y square, differentiate is going to be negative 2 over y dy dx. Next, we are going to differentiate our right hand side, which 4xy. So by using a product rule, we are going to do cross multiplication, and then we get d over dx 4xy equals to 4x dy dx plus 4y. So now we are going to combine all together and expand the equation. So for the second last step, we are going to move all the dy dx terms to one side and all the remaining terms to the other sides. Then we are going to divide both sides by the coefficients of dy dx. In conclusion, by using implicit differentiation, chain rule and product rule, we successfully obtained the derivative of dy dx given by this question.
I will explain question number 4. It will be our last question, and the question is about linear approximation. We are asking to estimate the value of bracket 1/0.03 the power of 2 minus 1 over 4 root 1/0.03. First, let fs equal to x power of 2 minus x power of bracket minus 1 over 4. We choose x 0 equal to 16 because it is close to 6.03. Differentiation the function f prime x equal to 2x plus bracket 1 over 4 x the power of bracket minus 5 over 4. Next, substitute x equal to 16, f16 equal to 255.5, and f prime 6 equal to 32.00 11 8. Using the linear approximation formula, fx equal to f at 0 plus f prime at 0 bracket f x minus at 0, substitute x equal to 16.03, f bracket 16.03 equal to 255.5 plus 32.00 11 8 multiplied by 0.03. Therefore, the estimate value is 256.460.